In stats, we talked about a follow-up to the smoking problem, and then we talked about power and a probability of type 2. So remember, we ended on Friday with this hypothesis test about non-smokers. So we ended up, some key parts, we ended up rejecting HO, saying that the true proportion is different from 0.5. And something I want to point out is that if we were to have worked on that problem last chapter with confidence intervals, the confidence interval would have given us something very interesting. So if we had done a 1 prop z interval with 95% confidence, and by the way, notice how 95% confidence corresponds with an alpha of 0.05. This would have given us an interval of 0.5216 up to 0.6784. And that's a big deal because remember the hypothesis was 0.5? And we had questions last chapter about checking to see if some claim is correct or not. And since 0.5 is less than the entire interval, that's significant. That's a big deal. So we could end up coming to the same conclusion, but I would say even stronger conclusion with a confidence interval, because now we have plausible values for that proportion of non-smokers. So that, I'll write that. This test is very similar, except the confidence interval is more informative because it provides plausible values for the true proportion. So in my opinion, a confidence interval is a little stronger, more beneficial than a hypothesis test. But people tend to like hypothesis tests more. So moving on, a type 2 error is when you mistakenly fail to reject HO. Remember, I told you this is beta. That's the probability of type 2. Well, there's this other thing, the complement of a type 2, and it's not a type 1 error. It's when you conclude the other way. It's called power of the test, and I would call it power. I mean, we have that typed textbook definition, but I like this definition a little better, is the probability that looks like a funny Y, of correctly rejecting HO. It happens to be the complement of beta. So if you know beta, you can get power by subtracting it from 1. You can increase the power of your test by increasing the sample size, or if you increase alpha, and I'm about to show you especially the alpha thing, why that would work. That bold sentence at the very bottom, that's more theoretical. Typically, we don't have the absolute true parameter. Typically, we only have a hypothesis. So that while that statement is true, it's more just in theory how to increase the power of the test. All right, let's actually work one where we find power and type 2. So this is the potato problem from last week. More of the same situation. You know, we're going to turn the truck away if it's significantly greater than 0.08. And later, we find out that there is a true proportion of 0.11. So maybe on your paper, write the true proportion. And this knowledge was gained after the fact. Like we ended up, maybe, who knows, maybe the truck went back to its home office and they counted all the blemished potatoes and it came out to 11%. The first question, what p-hat is going to cause them to reject that hypothesis? This is a very backwards problem. We'll deal with that 11% here in a minute. Let's back up and look at the original hypothesis. Hypothesis was right here, 0.08. We set an alpha of 0.05. Let's write it down here. That's alpha. And this first question is asking us what p-hat is right there. I like to call that the decision point, because that value is like that make or break point. If there's a proportion of potatoes larger than that number, we're going to send the truck back. If there's a proportion of potatoes smaller than that number, we're going to keep the truck and its potatoes. So that's like that decision point where it causes us to reject or fail to reject. And we need to find that value. It's very backwards. Alpha's 0.05, so let's work backwards. Let's do inverse norm and first find that z-score. Remember, with inverse norm, we can only use percentiles. So that has a 95th, that's the 95th percentile. When I type that into the calculator, I get a z-score of 1.645. Then I can do some algebra, plug into this guy, and solve for p, p-hat, and figure out what p-hat is at that spot. So I know z. I don't know p-hat. That's the decision point. I'm hypothesizing 08 with this standard deviation out of 500 potatoes. So you got a little algebra to do. Multiply both sides by that square root, whatever that denominator is, and then add 0.08. And you should get, after you round a little bit, 0.10. And that is the decision point. Some professors in college teach only with this value, because what that does, it's actually very useful for the public, for someone in their job. If p-hat is greater than 10%, reject. That falls into that blue shaded region, right? That's going to give you a smaller proportion. This is very backwards. It's like the opposite of what we learned on Friday. If p-hat is smaller than 10%, we're going to fail to reject, and we'll keep the truck. All right, now the hard part. Now that we have the decision point, it's 0.10, I need to find the probability of a type 2. And that's the proportion of z's to the left of that decision point. So what I need to do, let's do this. Is I need to find a new z-score based on the true distribution of blemished potatoes, which is 0.11. Now I need some room. I'm going to clear this out so I can draw a back-to-back bell curve. So the blue one is the hypothesized curve. This curve is the true curve, true distribution. It has a mean of 0.11, as it says up in the paragraph there. Let's make that a little better. And this is beta. All right, power is this shaded area. We have three different areas. We have alpha, we have beta, and we have power. Now the math isn't bad once you see all that. We're going to go decision point minus true divided by the true standard deviation. When we do that, we get a z-score of negative 0.7147. With that, I'm going to do normal CDF. Remember, I'm going to the left of this number. I'm looking at that red shaded area up there. Negative infinity. That's my low. Negative 0.7147 is my upper, with a mean of 0 and standard deviation of 1. And that'll give me a probability of a type 2 error. This is getting a little busy. And that gives me 2374. That's beta. All right, for power, once we're that far, it's piece cake. Complement of beta. And power of the test, power of us correctly rejecting HO is 7626. So there's power, there's beta, and the decision point was down here. So it required doing two different z-scores, two different probabilities, or two different normal CDFs, and you're good to go. All right, see y'all later.